all of you. Now this is one video which I should not upload at this point of time, because this is something about basic concepts of carbon and its compounds. When I started, but then when I started receiving messages regarding, messages from students to upload a basic concept video, because what I understand now is, for many of you, the basic concept of this chapter, carbon, it can be called carbon and its compounds, or it can also be called organic chemistry. Okay, it has both names, is not very clear. Okay, so I am taking up this particular video. I am not going to do nomenclature here, neither I am going to do any preparation, or I am going to do any esterification, any such equation. I am not going to take up any equations here. Okay, it is just I am trying to help you to understand this chapter, and then once you understand, you will see that remembering the equations becomes very easy. Okay, another thing I want to tell here, that once I finish uploading, once ICSE and CBSE is over, I shall be uploading 11th standard topics in maths. So please, if you have not subscribed till now, please subscribe the channel, because there are lots of important concepts to be taught very soon for 11th standard. Okay then. So firstly, why do we call it carbon and its compounds? Okay, the reason is, everything around us is, a whole lot of things around us is made out of carbon. I have a table here which is made out of wood, it is carbon compound. Okay, I have any paper here, if I have paper here, okay, paper is a carbon compound, it is cellulose again. Then if I have any other substance like the tree outside, carbon compound. Our bodies is a carbon compound. Okay, it is made up of carbon, hydrogen, oxygen and few more minerals. Okay, then anything, if you look around, even the curtain in the room is a carbon compound. It is, okay, it is made out of cellulose. If you see the tree outside, again it's a carbon compound. So except maybe for the for the iron, the grill, I can see some grills there, the window grills and all, those are made out of iron. It's not a carbon compound. But even my wardrobe made out of ply is a carbon compound. Okay, now what is a carbon compound all about, and why do we study carbon compounds specially, and we don't study nitrogen compound, sulfur compound? Okay, the reason is, carbon has a very special property called catenation. Okay, what is this catenation? Catenation is the ability of atoms to form long chain compounds. Okay, now if I talk about carbon, the valency of carbon is 4, atomic number is 6. So if I write this is the first orbit, and in the second orbit, this is valency is 4. Okay, so valency of carbon is 4. So this is outer shell has 4. Now any compound can either go for a covalent bonding or an electrovalent bonding. This cannot go for an electrovalent bonding because it is difficult for it to give 4 of them, give 4 electrons, because it is so close to the nucleus, and also on the other hand, taking 4 of them, okay, taking 4 electrons is also a difficult thing. Why taking 4 electrons is a difficult thing? Because it has only 6 protons inside. For 6 protons to hold on to 10 electrons is little difficult. Okay, so for these reasons, carbon goes for a covalent bonding all the time. Another thing is, if carbon is going for a covalent bonding, then in this, why can it go for catenation? Now these 4 of them go for it, they can go for double covalent, single covalent, anything. So if supposing they are reacting with, supposing they are bonding with hydrogen. Okay, so here carbon can actually go for catenation because it is a small atom. That means only 2 orbits. Okay, if it is only 2 orbits, it is easier for the protons to hold on to the extra electrons that are coming due to bonding. Okay, so here we form single covalent bond. Okay, and you will see as I proceed that carbon since the bond in this carbon compounds is very strong, as I said, because it is a small atom, it can link many more carbon atoms. So if you see the molecular formula of kerosene, diesel, okay, or even sugar, fructose, starch, etc., you'll see that they have a lot of carbon atoms. Sugar is C12H22O11. See the number of carbon atoms and see how big the molecule is. Okay, a total number of how many? 30, 40, 45. Okay. So 45 atoms in one molecule. So that is why that is what we call as catenation, the ability of an atom to hold on to many more atoms and form long chain compounds. Okay. Let's come to the what is this entire chapter made up of? This entire chapter has something called homologous series. Okay, something called homologous series. What is this homologous series all about? All carbon compounds are divided into categories depending on certain things. Okay, what are those? What are those certain things that I am talking about? Okay, depending on their formula, depending on their bonding, and also something else which is called the functional group. Okay, so now here if we have alkanes, then we have alkenes, then we have alkynes, and then we have alcohols, we have aldehydes, and then we have carboxylic acid. Now, that's a carboxylic acid. Here, I am not saying these are the only homologous series. After this also you have ketones. You can have many more, but the thing is ketones is not there in your portions. So we need to learn only this much. What are alkenes? Alkenes, if you see, they are made up of single bonds. Carbon-hydrogen combination, single bond. Okay, so if I say what is the first alkane, it is CH4. That is, I just drawn that also. This is alkene. You have drawn it. Methane you have drawn. Now if we take the second member, this is the first member of alkenes. The second member, carbon will increase by another one. Okay, so here it becomes C2H6. Note one thing here also. If we draw, I am not drawing it. It is again. And when we talk about single bond, double bond, remember we are talking about the carbon-carbon bond, not carbon and hydrogen bond or carbon and oxygen bond. Okay, so here hydrogen. So this is ethane. Similarly, you can have propane, butane, pentane, hexane. So every time the carbon atom increases by 1. So if you are using meth, this is also important, then it means 1 carbon. If you are using eth, means 2 carbons. Prop is 3 carbons, and it applies not only for alkenes, it applies for everything. Okay, bute, like butane or butene or butyl. Okay, that is 4 carbons. Pent, that is 5 carbon, or hex, 6 carbons, like that it goes. Okay, now here let's talk about alkenes. Now here one thing I forgot to mention. In alkenes, the general formula is CnH2n plus 2. Means what? This general formula is really very helpful. Here, carbon, if you put a 1 here, it becomes CH4, you get the first member. Carbon, put a 2 here, you get C2H6, you get the second member. So this N is the number of carbon atoms in each one. Now here it is CnH2n. Yes? Okay, and okay, so this is CnH2n, and that is now CnH2n, that means put C1 and we get C, and here in this alkenes we can't put carbon 1, because if we want to put carbon 1 we get this, and we can't get a neutral molecule like this. Okay, because we need at least 2 carbon We need at least 2 carbons. So my first member is this, and my second member is C3H6. Okay. Now what is the bonding like in this carbon-carbon double bond? Okay, here we start with double bond in alkenes, and now see hydrogen, so, and hydrogen and hydrogen. This is C2H4. Yeah, this is C2H4. Okay, if C2H4, this is how it is formed. You wanted me to draw this, I'll draw this. Now, keep counting the hydrogens and note here C3H6. So C3H6 is what? C3H6 is the second member of alkenes, and keep following the general formula. So learn up the general formula if you haven't till now. So now note one thing, I told carbon-carbon has to have a double bond. That doesn't mean all the carbon-carbons will have double bonds. Only one of them will have a double bond. Okay, how do I draw it correctly? Keep noting the hands of carbon. There should be 4 hands in each case. 1, 2, 3, 4. So only one hydrogen this one has. 1, 2, 3, 4. It has 3. Here because of the double bond it has only 2. Okay. So this is my second member, and we'll call it, this is ethene. Okay. Ethene. The name comes from this, and this is propene. Okay. Propene. Because of 3 carbons it becomes propene. Okay, so let's move on to the next homologous series. Now you see every homologous series is guided by one formula. Here it is CnH2n-2. This is alkynes. Okay, so the first one, if you put 1 here, then you can't get a compound. So C2, if you put 2 here, H2. This is ethyne, or okay, also called acetylene. So here ethyne. Now if I take the next one, which is 3, okay, then how much do I get? 6. This is 4. This is propyne. Okay, now comes alcohol. CnH2n plus 1 OH. Now it is from alcohols that we start with the functional group. Here for alcohols the functional group is OH. Okay. Now this functional group gives character to all the elements or to all the members of this homologous series. Each one will have one OH. Okay. Here this is, so if I take C1 here, then this becomes 3. Okay, OH. This is the first member of the alcohols. This is methyl alcohol. Take 2 and we get ethyl alcohol. Okay, like this we can even take 3 here. If I take 3 here, it becomes 7 OH, like this. So these are the different alcohols. And then come to aldehydes. Here the functional group is a CHO. General formula is CnH2n plus 1 and then a CHO. Okay. So my first member is, if I take 1 here, CH3CHO. My first member here is a CH3CHO, which is acetaldehyde. Okay. Now I can also get an aldehyde here, HCHO, that is formaldehyde. Okay, where I just take N to be 0. If I take N to be 0, I get formaldehyde. Note here, I'll put N0 here. This will become this will become only H. Okay, and then CHO. Let's come to carboxylic acid. General formula CnH2n plus 1 COOH. That is my general formula for carboxylic acid, and the functional group is COOH. This is the place C. You can see the functional group written like this. Okay, functional group is COOH. Now, what is the first carboxylic acid? HCOOH. This is formic acid. Then CH3COOH. Okay, C2H5COOH. So this is acetic acid. Then we have Then we have the next, this is acetic acid, and then we have the next member where, so here carbon was taken as 0, here carbon was taken as 2. Okay, now the functional group in each one you can see is present here. Okay, without this functional group you will not get this member of the homologous series. These are the ones which don't have a functional group. Now let's come to one thing very important, that is when we come to any compound which has a single bond, okay, like this alkanes, okay, alkanes has a single bond, here double bond, okay, I haven't drawn this, I should have drawn it. This is a triple bond, okay, this is where we have triple bond in alkynes, I forgot to draw it. So this is the one which has a triple bond, all of these will have triple bond. Now this is a double bond, triple bond, single bond. As long as it has a single bond, it is a saturated compound, okay. So we have, this is a saturated compound, and these two are considered as unsaturated, okay, these are unsaturated. Now why this name? When it is a single bond like this, it cannot, you want to add chlorine to it, it does not have place for it, it does not have electrons left for it. Okay, so what it will do? It will remove one hydrogen and then bring in one chlorine. So saturated compounds will always go for substitution. Okay, that is in place of something else. So your one teacher is absent, in her place another teacher comes to teach, that is substitute teacher. So this is a substitution reaction. Saturated go for substitution reactions. Let's see this when you have unsaturated, even this, okay, unsaturated reactions. Now you want to add chlorine to it, it has lots of electrons. Why? Because here 3 electrons here, 3 electrons here. What happens is they just reduce the number of, from triple bond they become double bond, okay, and now they have 1 electron free here, 1 electron free here. That electron combines with the, let's say, chlorine, so it is going to combine with the chlorine. Now what happened? This one or this one will open the double bond, become a single bond, and then take in more chlorine. So these two go for addition reactions, okay, they go for addition. So unsaturated compounds always go for addition reaction. On the other hand, saturated compounds go for substitution reaction. Very important question. Okay, let's talk about something else that is again important. That is, what is the difference between molecular formula between each member of a homologous series? Like I have one, these are each homologous series. Now in each one of them, how much is the difference between two members? Clearly I can count for all of them. Here there is 1 carbon extra, 2 hydrogen extra. You keep counting, it is always a CH2, note. Okay, it's always a CH2. Here also it is 1 carbon and difference of 1 carbon and 2 hydrogen. Here also, note here, it's a difference of 1 carbon and 2 hydrogen. Everywhere you can see between two consecutive members of the same homologous series, it is a difference of 1 carbon and 2 hydrogen. Okay, total comes to 14 according to molecular weight, because carbon is a 12, hydrogen is a 2. Hydrogen is a 1, 2 hydrogens make it 2. So total is a 14. So it can come in your MCQs. So total 14 according to molecular weight. Okay. So every two consecutive members differ by a 14. Okay. So I think this much is enough for the basic concepts: saturated, unsaturated, homologous, functional group, single bond, double bond, triple bond. Okay, general formula, very important. Learn this up. It will help you in your IUPAC nomenclature also. When they give you the structure and ask you to name it, then it really helps. When you have to draw the structure, it won't come of any use. But you have to understand the name, then it is very useful. Okay, so this is it from organic compounds. I thought this basic concept will help you for for understanding the equations. Okay, how do you change one carbon to another? Why do you see substitution reactions only for alkenes and you don't see them in alkenes and alkynes? I don't know if you have noted it by now or not. Okay, you will not see substitution but addition reactions for these two. Okay, then That's it for today. Thanks then. Bye.